It's been a great session, and I think it's a nice time to transition to some of the questions that were raised by Kim around how might we enable getting better access to the kind of data for people that are, in remote locations where, and we live in a challenging time where it's difficult to see them in person. And this was one of those things that were bred out of necessity. I had never imagined that I was going to be doing as much online testing as I am now, and so we're really trying to push the limits of what we can do. So I just want to give you a reminder what March 2020 looked like. At the time, I had no idea that the most exciting part of my vacation was that I was in the epicenter of an emerging pandemic, but that's where I was in California. Little did I know that that would be the last time, the day after I got back would be the last time that I was in my lab. And so as all of us are struggling with doing science in the laboratory is challenging, and that's what I want to talk about today. So at that exact time, I was working with Dr. Dana Hayward in psychology, as well as my grad student, Jennifer Bertrand, and an undergraduate, Helen Ma. And we had just asked for funding for a project that was going to do something like this, which was collect eye and motion data from two people simultaneously playing a simple card game. This is not a trivial task. It was going to be ambitious at the best of times, but we were excited. I think we have the wherewithal to actually collect this kind of data. But of course, at the same time as this, pretty much everywhere in the world was getting shut down. So the dreams of having anyone face-to-face, let alone two people face-to-face, wearing equipment on their heads, performing this kind of experiment was just impossible. So that really brings up the problem that I was facing at the time, almost a year ago, which was I need to be able to collect data. Obviously, I need to be able to collect what I'd call conventional data, so questionnaires, survey responses, button presses, reaction times. This is sort of the bread and butter of a lot of what we want to do. But in my lab, I also want to collect sort of that next level of data, what we refer to as gaze and movement data, or as I will refer to it throughout this presentation, gamma information. Here I'm talking about motion tracking and eye tracking specifically, but we're interested in any and all modalities that we might be able to track about a person's movement, how they're thinking, what their physiological responses are. And then I had this added burden that we were going to try to get into the space of two people interacting either with another person or with objects in front of them. And of course, by the end of March last year, it became patently clear that this needed to be happening online. And I say this as someone who until last summer had never collected a single data set online. And I've collected tens of thousands of data sets, but not one of them was conducted via a computer other than in a laboratory setting. And so this was, to me at the time, an incredibly daunting task. And so I'm here to pitch to you guys a solution that has worked incredibly well for my laboratory, and that is this online experiment platform known as Labvanced. Full disclosure, at the time, I was only a customer of Labvanced, but I've become such a believer in their product that I've actually reached out to this team to see if I can work with them to help promote their product. There's no finances attached to this yet, but this is something I really believe in. And as you'll see, I hope I can convince you guys it's an extremely powerful product. Just to give you a quick flavor, it's essentially a graphical user interface or GUI front end to JavaScripting that allows you to script full online experiments with a lot of flexibility and complexity. A couple of caveats: it's not free. So it's been one of the best investments for my lab to spend what was around $5,000 for the last year for full online experiment design and data collection. Or if you were a single user and wanted to classify yourself as a student, it would be about $1,000 a year. So it's not free, it's not no money, but it's also not an exorbitant given the flexibility and what it's capable of doing. The other thing I want to mention is if you're going to make it pivot your studies to online, as many of us have faced, you have to go through ethics protocol. And I do want to applaud the REB at the U of A has been excellent throughout this process in helping to facilitate the transfer of current existing protocols to be retrofit for online data collection. And they've been very helpful and very efficient with that, but it is a step that everyone needs to take. So I'm not actually going to talk about this study, but I'm hoping the videos play for you a little bit. We were actually able to succeed in a two-player online, what we call dyadic decision-making task, where players are required to, with their mouse, reach out, click on, drag cards. So in the top left, you're seeing what one player sees. In the bottom right, you're seeing what the other player sees. This is happening in real time. I'm seeing how you're moving. I'm sometimes seeing what cards you're choosing. Sometimes I'm not. We're able to hide information and really play a complicated decision-making game, again, in real time with two players. And as of last night, for the first time, we actually have a data set where this also is capable of collecting eye movement data from both players in real time simultaneously using webcam technology. So if you would have told me that this, when I was in California last March, I would have laughed, but we've made huge strides and it's really enabled by this platform. So if anyone's interested in collecting this kind of data, please feel free to reach out to me. We've learned a lot about what we can do with it. But I want to go into a few other examples that I think will be relevant for this group. I'm just going to go through 4 quickly and just show you what it can do without getting into the details, and then happy to open it up for questions. I'm going to look through an example of basic decision making in a foraging task, an applied research domain with an industry partner looking at a 2 alternative mouse tracking task, looking at replicating a movement neuroscience lab that we actually deployed for an undergraduate class last fall. So we were able to replace an in-person laboratory component entirely by using a Labvanced lab for them. And finally, a sensory motor assessment that is actually aligned with the Smart Network Innovation Fund Award. Before I move on, I want to acknowledge that one of my graduate students will be absent in this talk because unfortunately, as great as Labvanced is, it doesn't do virtual reality. So I'm sorry, Ewan. I tried to draw you a downward smiley face. It turns out it's really hard not to make it just look like a mustache, but I tried my best. Okay, so here's the first task. So I'm not here to talk about the results of these tasks. I just want to show you what's possible. But very quickly, this is a foraging task where you're controlling a little red cursor on a screen, and you're trying to collect points by moving that red cursor to grab things that are worth 15 points in blue or 5 points in green, and you're doing it just by pressing up, left, down, right arrows on your keyboard. And on the left, I'm showing you what existed as of the spring of last year, which was a MATLAB-based version of this task that we were capable of running in the lab. And on the right, I'm showing you what we were able to replicate in Labvanced. So we were able to entirely recreate this task in this online web deployed platform, and now just have access to mass amounts of data collection via sort of the crowdsourcing or MTurk in this case data pools. So we were able to collect a massive amount of data. In this particular study, and at most MTurk studies, you pay about $5 to $10 per subject that uses the platform. Here we were able to collect more than 60 participants in much less than 24 hours. If anyone's ever used these types of platforms before, you know that almost as soon as you post your studies online, they're already filling up with slots. What I'm going to show you is just the kind of data that we can collect. So this is all 66 participants on this trial plotted as they hit their button presses in the actual amount of time that they took to hit their buttons. So I'm trying to show this to you because this is all data that's generated and harvested from the online platform. So not only do we know which targets they chose to go towards, we know exactly when they hit the button every single time. So we know there are precise decision points where a group of people might find that decision hard and spend longer. We know the individuals that are more deliberate and take a long time to traverse. And as this thing cycles back to the beginning of the clip, we can actually see these huge scale patterns of like decision-making behavior where we have one cluster that decides to go up, one cluster that decides to go to the middle, and a couple people that decide to go down. This is an incredibly rich data set that was generated, as I said, in less than an hour after we made the pivot to an online platform. So the amount of data we can collect is pretty astronomical here. The second example I want to give you is a MyTax partnership we have with the startup in the UK called Neurosight. They're interested in what we can learn about your decision-making processes by analyzing your mouse trajectory movements. And they've been developing an online platform called Horizon. So here's a video of what Horizon looks like. It just shows you 2 pictures in this case. You have to choose which one you like more. And we can do this with a variety of stimuli. So here you're judging the truth value of a sentence, whether or not elephants are large. And finally, in the last one, example of a trial, you'd have to decide which of 2 numbers is numerically larger, a 2 or a 1. And so they've been developing this platform, and we were literally in the process of validating this in the lab where we had full control over what computer people were using and the kind of mouse and all of that kind of stuff. And then Alex got interrupted after about 15 data sets, and we had to move to data collection using Horizon Online. But it was very challenging administratively to get the kind of data we needed or the quantity of data we needed. So again, we turned to Labvanced and recreated the task in Labvanced. And the point here, I hope, is that you can't really notice the difference. I have switched slides. This is recreated in a completely new online paradigm where we actually have more control over how the data is collected and what data is collected. But from the experience of the user, we're hoping it's seamless. They don't even know, if you put them side by side, that they were doing two tasks. The advantage to us to flipping to this online platform is, again, that we can leverage mTurk, and here we can collect or have collected more than 300 participants of data. And again, it's on the matter of days. You can collect, these huge sample sizes, or what for my lab would be huge sample sizes, in a matter of days. And it's also worth noting that we're not restricted to a single device type. And this is one of the things that I'm the most excited about, and I think is referring to Marilee's earlier question about how do we make this technology or these assessments more accessible? Well, one way is to put these assessments on smartphones or on tablets, where I think the barriers to the barriers to technology are reduced. People feel more comfortable with these devices. And indeed, we about 100 of each of these data sets comes from people doing that task on a tablet or a phone. Of course, collecting the data is only half of the problem. The other half is analyzing it. And I'm not really here to give a pitch for the software development that we've been working on in Gamma, but that is a big effort in my lab, led primarily by Quinn Bozer and Riley Dawson, who are two fabulous research associates that I've been able to work with in developing a tool that lets you take your gaze and movement data and analyze it in very sophisticated ways and automate that analysis. So in this particular case here, I can show you this data now as a trial in the Gamma engine, where you can see now where the mouse cursor moves and how it moves across the screen. And then we can take the output from Gamma and do more sophisticated analysis on it. So not just how quickly you move, how quickly you react, but instead also measures of your deviation. Here I'm showing in light blue a measure that we call maximum absolute deviation, which is how far are you away from a straight line path. And this is a direct measure of how competitive you found the option that you didn't choose. And this would be completely absent unless we can harvest the trajectory data, which again, this online platform allows us to harvest in great quantities. The third example I'm going to go through is, again, for use as an educational tool. We were able to use Labvanced to present a laboratory to students who would usually have to have done it in person, but instead we were able to do it online. For those of you who aren't familiar, Fitt's law is a classic, maybe the classic example of a speed accuracy trade-off in the movement domain that simply states that movement time is going to take longer if you have to move larger movements or bigger movement amplitudes, and you're going to move faster if you're moving towards bigger targets. And so the beauty here is that we actually gave students the power to explore this parameter space on their own. So again, in Labvanced, we designed a task that allowed them to visualize what their experimental conditions might be, and then just mess around with the variables and see how the variables might change performance. So that was a change in target size, and we similarly allowed them to change target position. And the cool thing here is that they got to choose the combination of factors that they wanted to explore and run for their experiment. It was sort of a level of autonomy that you conventionally cannot get in laboratory environments where you have to follow a rigorous protocol. They then took those parameters and were able to input it into another Labvanced task that actually collected data for them. So I think that here you can see the actual experiment that's running, and I'm sort of doing it so that you guys get a feel for a person has to click back and forth between these very skinny targets. It's really hard. But what's happening in the back end is data is being generated and collected for the student who's running the experiment. So they become the experimenter. And then it cycles through their different conditions a number of times. It runs a full, proper repeated measures design without them having to tweak and figure out the details. They can go through the process of designing an experiment and collecting data. Now, thanks to the work of Jennifer Bertrand, my graduate student, she wrote a really detailed lab manual for this task. It's about 15 to 20 pages long, goes through every step, every button they need to click, So this is kind of like a ready to go lab for anyone that wants to do a Fitts law or movement neuroscience, lab. This one's done. And as you can see in the bottom box, this is the data that gets automatically returned to the experimenter, in this case, the student. We have measures of accuracy, time, and spatial and temporal errors, all of which the student can access. And I think the biggest testament to the success of this approach was that we were able to generate the students generated 30 different lab reports, all of them with data when there was no problems with the data collection. So we successfully administered a lab with no glitches, which anyone who knows trying to run these labs in person, that never happens. But by switching to an online engine and giving them control, we got, I think, just sort of beautiful data collection automated, and with them having some autonomy. The last example I'm going to go through is really, I think, the one that gets us the closest to imagining how we could use this in a rehabilitation setting, although I should say Fitts law has been used for that. And this is part of a project that Jen received money for from a Smart Network Innovation Fund in order to understand how we can look at eye-hand coordination during object interaction in more reduced settings. So here was the task that Jen had designed for use in the lab. This was, again, implemented in MATLAB. And initially, this was designed where we were also simultaneously collecting EEG data from a consumer-grade EEG system. Now, that is the component that has to have been removed. We can't collect EEG data from users, obviously, in their own homes. But using Labvanced, we can collect eye gaze and movement information. So here is the exact same task, but now deployed using Labvanced online. And I should mention that the red circle is just a result of the screen recording software. So what you see here is exactly what the participant sees. And what you can't see is that we're using their webcam to get their eye gaze data. That becomes more clear when we show you the visual representation of that task in Gamma. Again, this is our software platform. And now we can see the triangle is the mouse position, the pink dot is the eye position. This is uncleaned, unfiltered data. We haven't done anything to it. And Jen actually tells me that her puppy was on her lap while she was collecting this data. But this just goes to show you, we can collect pretty accurate eye gaze and movement data from people using their own desktop computers. As long as they have a webcam and a mouse, we can get gaze and movement data, which I can't tell you how exciting that is. That's going to give us sort of a new way to tap into sensory motor assessments. So just to end, I want to say that, I've been forced to realize, and maybe this is the opportunity that COVID has presented my lab, we can get motion tracking data from mouse cursors. We can get eye and head tracking from webcams. We can get other things that we haven't even explored, like audio, video, chat, recording, perhaps other physiological monitoring like pupillometry or other sensors that the person has in their home. And we can feed all of that through an online platform like Labvanced, and then use something like Gamma, our software tool, to automate the extraction of metrics from that data. This is an incredibly convenient and cheap way to collect data. I can't stress this enough. There's no way I'd have data sets of hundreds of people if I was still in the lab, but now I do because we've pivoted to online. It can be in a person's home. If they have a computer with a webcam, they can sit down in 5 minutes. You can be assessing their sensory motor performance. Or in a clinic, it doesn't take more than a desktop computer, and almost every clinic has one of those. Again, you get big samples and the opportunity for longitudinal data, even day of time data. Are you the same at performing this task in the morning as you are at the end of the day? But certainly throughout your rehabilitation journey, how are you recovering? How are you changing? And I'll end with saying that I think this is the future of telerehab, or part of the future of telerehab, is exploiting these technologies that we all already have access to in our homes to harvest really sensitive sensory motor data. But I don't want to leave Ewan out in the cold. I want to leave him happy. And I do want to give a shout out to the fact that Ewan, together with Martin and Nathaniel, we have received a small amount of funding to do the same thing in virtual reality. So I think VR is one step up on the sort of food chain of technological barriers, but it also gives you access to full three-dimensional data. So all of what I said will apply to VR, and I think there's an exciting opportunity in both cases. So I will stop there and happy to take questions or leave the questions for the roundtable.
Thank you very much, Craig. Really interesting presentation. I think that I'll give you one question, and then there's 2 or 3 that we'll save for the roundtable. Marilee asked, how hard is it to screen subjects when they're all applying online? How do you know they are who they say they are?
Yeah, so I think that's one of the risks of going with big data testing online is you have to take their word for it. You can, of course, integrate all of the typical demographic or other questionnaires that you would use in the lab to screen participants. So I didn't show you any of that, but all of the tasks we're deploying in Labvanced have, of course, consent up front, and then after consent, several pages of typical survey questionnaires where people self-identify, gender and socioeconomic status. But yes, you're taking it on faith that they're answering correctly. On the flip side, MTurk specifically and other communities are very well regulated. They get compensated and or flagged for good and bad behavior. And so the community itself sort of self-corrects. And to be totally honest, the quality of data that we've gotten so far is overwhelmingly good. It's at least as good, I think, or almost as good, I should say, as the data we can generate in the lab. So yes, I have some concerns, but actually with the benefit of how much more data we can collect rapidly, I think it far outweighs that possible issue.